Thank you, Dr. Joe, for the introduction. Well, today I'm going to speak about mastering environment control in indoor farming. So, how to improve crop performance with CEA technologies. So, let me start speaking a little bit about myself. Why are you supposed to pay attention to this tiny person in front of you? Well, my name is Carla Garcia. I have a master in plant sciences from the University of Arizona. And right now I am on technical service in North Americas. My job in here is to answer questions and provide all the information to customers that they need, not only about the products of the products that we sell, but also about everything they need to know to make sure that they are successful. And also, as Dr. Joe mentioned, I am a short course instructor in Mexico. We have teach more than 100 short courses in topics like hydroponics, urban farming, greenhouse design, and aquaponics. So, what is Horta Americas? Horta Americas is a company that is based here in Texas, and we provide greenhouse and hydroponic solutions. But the difference of this company is that we sell products, but we also have technical service. So we want to get sure you receive all the information you need through all your project to make sure you are successful. So let me explain a little bit about what I want to speak today. So basically, we are going to learn about different variables that are very important in indoor farming. So these variables in here are temperature, airspeed, humidity, CO2, and light. Sometimes when we are working in indoor farming from a greenhouse or different kind of systems, make sure you know this you know these kind of variables, because that can make the difference between an investment of a waste of money. So we want to get sure that you know how to manage the system. So I think everyone knows what everyone is speaking now about, like how we're going to supposed to feed 9 billion people in 2050. That is something that we always heard in every conference related to this kind of field. So in North Americas, we know that we have this issue that will happen in the future, but we want to focus on one thing. Why does that matter now? So why is that important now? So basically, we need to get sure now we know how to apply CEA technologies to improve food production. Not only for the future, so also because we want you to be successful now. And later, you can use that success as a tool for tomorrow when we're really going to need that information. So what is the importance of CEA, for controlled environment agriculture? One of the advantages of these systems is that we can farm more in less space. This can be translated to we can have small growers with bigger business, which is something really important. And also we can increase production window. We can have a year-round production, which that can translate to have a lot of food and also annual contracts for all the growers. Also, another important thing about CEA technologies is that we can have the interest of the customers, because we can offer a different product that is locally grown, and we know that people is now caring about that. I mean, about product that is really fresh, that is pesticide free, and also they can improve their diet. Other advantages of CEA technologies are that we can provide local jobs to our communities. We can reduce shipping. We can reduce also the environment impact, because we can apply technology that will help us to, for example, save water. And we can improve food quality, because now we are so worried about shelf life. And if we have small businesses across different cities, then we can now focus on the important thing, like having products that taste good and also with good food quality. So what is indoor crop production? Indoor crop production involves different kinds of systems. This goes from hydroponic greenhouses, vertical farming, container farms, and also in-home systems. So all these imply what is CEA. So these are the variables that I'm going to speak about today. We're going to learn very general but important information about these variables that are very important in CEA technologies. So first one is temperature. If we can control temperature, we can optimize plant development and also translocation of carbohydrates. Also, I'm going to speak about wind. That wind is not only important for uniformity in your environment, it's also important for photosynthesis. And I'm going to speak a little bit about light. Light is very important, so we have one presentation today focused on light, so I will just briefly over this topic. And I'm going to speak about also humidity, how to optimize nutrient uptake in different crops, and also about the nutrient content and the CO2. So let's start with temperature. Why temperature is important and how can we manage this variable to get sure we can improve the production. So here we have, in the x-axis we have temperature, in the y-axis we have photosynthesis. How the plant responds to this variable. When we start to reduce temperature, the first thing that will happen in a plant is that we are going to start to reduce the metabolism. That is the first response that we will have. After that, obviously we will have stress and the plant will eventually die. What happens in the opposite side? If I start to increase temperature. If I start to increase temperature, the first response that the plant will have will be to increase the metabolism. After that, we will have stress, the proteins also won't stop working, and then we will have problems. So we can separate temperature response into parts, like day temperature and night temperature. Day temperature will affect photosynthesis and transpiration, and night temperature will affect dark transpiration and elongation. Let me provide you an example so you can be sure how this works. For example, here we have tomato and some recommendations about the temperature that we recommend to grow this crop. So as you can see, there is a big difference between the temperature in night and during the day and night. So this difference is not because the plant needs that temperature to grow. This difference in temperature is because we want to get the plant to work the best as possible. During the night, the plant starts to do dark respiration, and we know that nearly 75% of the energy loss occurs at night. So what are we doing by applying low temperature at night? The purpose in here is to reduce the metabolism of the plant. We want to reduce the metabolism of the plant at night so the plant can save energy and start the next day working, and then we will have more carbohydrate translocation. This has been improved not only for tomato but for strawberry. We know that if we have low temperature at night, we will have more tasty strawberries. So what happens on the other hand when we start to increase temperature? When we start to increase temperature, then we will have an increase in the metabolism. This is something that we don't really want, because if we start to increase the metabolism, the response of the plant will be to enhance the development. This means that the plant will start to make more flowers, for example, but the energy is the same. The plant is just working more. So what this means? This means that we will have more flowers, but the flowers will be smaller. And if we have small flowers, we will have small product, which I think is something we don't want. So make sure that your plant is always within the range of the temperature that is recommended. And it's also very important to know that plant responds to average daily temperature. What this means, plants will respond through the temperature, to the temperature that will have through the whole day, and then it will change the way it works. So you need to be sure, for example, if you apply this treatment to tomato, you need to get sure that you still have the range of temperature, your average will be within the range that is recommended. Because if you have a lower average, then you will start to reduce the development of the plant. That means that we will probably have more days to harvest. So always remember the plant will respond to average temperature, and that can also help you to manage your system to get sure that plants can get the average temperature that they need, and probably that can be something that you can manage in your, if you have, for example, a cooling system, and you can know how to play around with the temperature, so at the end of the day you have the temperature that you need. And this is just an example of what is increasing the temperature, or what can lower the temperature, reduce the temperature in your greenhouse. If you have condensation, if you have aspiration, it will have a good airflow over the canopy. So what is in this slide? In here what we see is a leaf, and we have the stomachs. These are small holes in the leaves. And what happened with wind? Wind will, when wind comes over the surface of the leaf, we will have friction in there. And then that will create a friction, it will create a kind of bubble of heavy air. And the name for that is boundary layer. So the boundary layer is this bubble of heavy air that will be in the surface of your leaf. Which means that the stomates that are trying to do this gas exchange to make photosynthesis and also transpiration, they will have problems doing that gas exchange if we have a big boundary layer. So in here we have a stomata cavity. In the stomata we have different resistance, but the boundary layer is a resistance that we can easily remove. How can we remove the boundary layer? By applying ventilation. So the boundary layer will be affected by the current speed of the air that you have inside of your system, and also the leaf shape, of even the shape of your crop. For example, a crop that is very common in having this kind of issue is lettuce. Lettuce is a crop that we know that all the leaves grow like together, and the new leaves of lettuce are just in the center of the plant. So in here we have, obviously because of the shape of the crop, we have a big boundary layer. So if we have a big boundary layer, which means we don't have good airflow over the canopy, this can cause tip burn. Tip burn is a deficiency of calcium. The deficiency of calcium will occur at the center of the plant. You will see dead tissue. The function of calcium is to be part of the cell wall. If we don't have enough calcium, the cell will form, but the cell wall won't have enough calcium to be formed, and then it will die. So we will see this symptom, which is something really common in closed systems for lettuce production. So how can we reduce this issue or solve this issue? By applying good airflow over our canopy. So in here I am showing different kind of fans. This is a vertical fan that will provide wind to lettuce in a very nice way. And this is a regular fan that is just horizontal. So if you use this kind of technology, you will reach about 0.2 to 1 meter per second of air velocity. which is something that we want to, or we need to avoid at least tick burn in our lettuce. And obviously there are a different kind of sensors to track this kind of variable. By the end of the presentation, I will speak a little bit of this. So now humidity. What is important about humidity? So in this section, I will speak about BPD, because I know that a lot of growers, they don't have a lot of knowledge of what is BPD or how to use it. So byproduct pressure deficit, or BPD, is the amount of vapor that can still be stored in the environment before reaching condensation. Why is used by the growers? This measurement is used by the growers so they can know how much humidity can apply to their system before start to see drops of water, and that is something that you really don't want, because if you have drops of water in your system, you will have fungal attack. This is something really bad. So we always need to get sure the humidity is within the range of the crop that you are using. And by tracking the BPD, you will know how much humidity can you still put into your system. So the BPD correlates directly with transpiration. If you have more BPD, if you have a higher BPD, you will have more transpiration, which is something also important, because transpiration, when the plant is transpired, that means that the plant is healthy, plant is moving water, plant is moving nutrients. So here I have a very straightforward, so it's easy for you to understand, that if you have a higher BPD, then more moisture can be held in the air, which means that your environment has low humidity levels. And when you have a low BPD, then that means that you have less moisture in the air that can be held in there before condensation, which means that your environment has more humidity. And obviously, there's also sensors to track this variable. Here an example of an issue that can happen if you don't control humidity in your system. Still speaking about calcium deficiency, but now in tomato. So in tomato we can see calcium deficiency in leaves and also in fruits. In fruits you will see this kind of issue that we call blossom emerald, which is to have necrosis in the fruit. So this can happen because of two different reasons. If we have conditions that are suppressing transpiration, that will mean that the plant won't move any water, or will move less water. If we have less water moving in the plant, that means that we have less calcium moving in the plant. Calcium in the plant moves within the water. So if water is not moving, calcium also won't move. So under this condition, if the plant is not transpiring, then the water won't be taken up by the plants, and we will have a lack of calcium in leaves and also in fruits. But what happens when we have an excess of transpiration, when we have too much transpiration in the plant? If we have too much transpiration in the plant, then the movement of water will be so quickly that the calcium will reach only the leaves, and we will not have calcium in the fruits. So in here I can explain it better. So if we have low transpiration, that would mean that the water uptake will be reduced, and also calcium will be reduced. So we will have the symptoms of lack of calcium in the fruit and also the leaves. And when we have an excess of transpiration, that will mean that the water will move so quickly that the calcium will go straight forward to the leaves and will avoid the fruits. So in this situation, we will have the symptoms only in the fruits. So it's very important to pay attention to your crop, because as you can see, these two problems are very similar, but the way we solve this issue is completely different. So moving to CO2. CO2 enrichment, yep.
Can I ask a question?
Yep.
Is BPD the measure that you use, or do you use like percent humidity? And then how good is the
You can use both. You can use BPD or percentage of humidity. Both can tell you the same information, right?
Can you repeat the question, please, so everybody can hear?
Yeah, so the question was that if we use BPD or percentage of humidity, I mean, which variable should we track? We can track both. The both variables will tell us, I think, the same thing, right? So we can use both. And also, what was the second question, sorry?
How many plants do you know that it's like an optimal humidity for growth?
Okay.
How good is the data out there?
So the question is, how good is the data to know how much plants and the level of humidity they will need? We have a lot of information about different crops of the humidity they need. So you need to focus on your crop, and then I can tell you like an average percentage of humidity, which is from 60 to 70%, but that will be different between the crops. So for example, strawberry need more humidity, like 75% humidity at night. So you need to focus in the crop and then do some research about it. And there's a lot of research out there. We can help you with that. So well, moving to CO2. In here we have a graph where we have in the x-axis the CO2 concentration, and in the y-axis we have the net photosynthetic rate. So not all the systems need CO2 enrichment. That is something important to know. But if we have a CO2 enrichment, there is research out there that have proved that we can have more yield. So the thing that we need to know is that plants have a compensation point. I mean, if you have levels below 100 micromoles per mole, you will probably have issues in your plant. And there's also levels of saturation that this level would mean that if you increase, and increase the CO2, the plant won't do more photosynthesis. And there's recommendations, for example, for tomato, usually in greenhouses, they apply CO2 enrichment to try to reach 800 or 1,200 ppm of CO2. And now speaking about light. Remember, we have a special tag for light, so I will just briefly over this topic. So in light, all the plants, all crops have a minimum light requirement. And this minimum light requirement can be tracked by a variable that is called DLI, which is daily light integral, how much light the plant. So in here I have a table, and we have the minimum and optimal levels for very common crops like lettuce, microgreens, strawberries, sweet pepper, cucumber, and tomato. So all plants, all crops have a minimum and optimal level. So how can we use this information? For example, this is a chart from Tucson, Arizona, and the DLI that they have within 1 year. So the x-axis is the days of the year, and the y-axis is the DLI. So as you can see, we have, for example, if we go to the middle of the year, which is the summer, it means that we have way more light than the optimal level. This is not bad in terms of photosynthesis, but what happened during these days that we have a lot of light, we also have a lot of temperature. So by knowing the DLI, the optimal level of DLI of your crop, you will be able to know how much light can you move from your greenhouse. Because if you already have theory, a DLI of theory, then that means that you can remove the rest of the light with a shade cloth or with a product like this one's from Supla that I will explain later. And then your greenhouse won't overheat. So if you have, for example, in here, a DLI of 60, that means that you have a lot of light that is only heating your greenhouse. You don't need that much light. So now let's move to the products. What we have to offer to track all these variables. Oh, sorry.
Does it matter the type of light?
The type of light, does that matter?
The question was if the type of light matters. Yes, of course matters. That is why we have a lot of artificial lighting right now. So, but I will let do the presentation of light, because I know that the Dr. will speak about the light. But yes, usually colors like red and blue are very important for photosynthesis. So moving to the products that we have a very nice product to track all the variables that I explained today. This product is 30 megahertz. 30 megahertz is a platform where you can connect a lot of sensors. We can offer you sensors for monitoring air velocity, CO2, PAR, which is the light, how much light your plant are getting, the humidity, and also microclimate, which can measure percentage of humidity and also VPD. So everything is connected to a platform where you can analyze your data and you can track this from your cell phone or your computer. So it's very easy to use and manage, and you can share that with all the people that is working with you. It's very nice. And we also have not only products to track the variables, but also to improve all the values. This is the booster plant multifan. This is a vertical farm that can be used, for example, for lettuce production. This fan is very nice and will create a very nice airflow for head of lettuce, because the head of lettuce will have better response if the air goes in a vertical way. And for the management of temperature and light, we offer this product that is Sublak. Sublak is kind of a paint that you can apply to any kind of glass or plastic in your greenhouse. And this is very nice because you can not only reduce the light that is getting into your greenhouse, but also modify how the light is entering. For example, this product is Optic Fuse IR, and this product will not reduce the amount of light that you are getting, so you are getting still all the light, but when the light enters the greenhouse, the light will be scattered. That means that you will have diffuse lighting inside of your greenhouse. Diffuse lighting inside of the greenhouse is something really good for tall crops, because when you have a tall crop, then you have multiple levels of canopy. And if you have direct light, the light will only be in the upper part of the canopy. So if you have diffuse lighting, you will have the light going through all directions, will reach the lower parts of your canopy, and also when you have direct light, you will have your leaves will be hit by the sun. So if you have diffuse lighting, you can also reduce that issue. So you can make that with OptiFuse IR. And also something important about this product is that you will get all the light, but you won't get all the heat. So all the short radiation of the sun will be, you will have some, but not all of the heat. So you will avoid the overheating of the greenhouse. And we also have other kind of products like Eclipse LD and Sombrero. These both products will reduce the amount of light that you are getting and also the amount of heat that you are getting. So this works like a shade cloth, but you will have a better light entering. And of course we have artificial lighting. That is very important, as the question that someone made to me. Light spectrum is really important for our plants. So there is a lot of research out there about how the colors will affect the plant growth, and we can offer multiple types of lamps. These lamps that in here are for top lighting, which means that you can make, for example, indoor production or apply supplemental lighting inside of your greenhouses. We have the Arise Element L1000. This is a replacement for high pressure sodium lamps because of the light quality, and also it can provide more than 1,000 micromoles. And it's is obviously more efficient because it's based in LEDs, so it's more efficient than high-pressure sodium lamps. We also have high-pressure sodium lamps. This is the GE H1000. This kind of light is very nice. It has more than 10,000 hours of light, and the input of the light is higher. You can get more than 2,000 micromoles per second. And obviously we also have light for vertical farming, so if you're planning to grow lettuce or microgreens or different kind of leafy greens, which is the crop that we usually grow in vertical farming, we have multiple options. So if you reach us with the crop that you want to grow, we will get you the information that you need to make sure you select the best light quality for your crop. So if you are growing microgreens, or if you're growing transplants, or if you're growing different kind of crops, the plants respond very different to light colors. So we want to make sure that you will get the light quality that the plants will need to make the production that you need. And we have all kind of products. We have all kind of products for hydroponics and greenhouse. And greenhouse production. So if you are doing hydroponics, we can have something for you. You can reach us, and we can probably share information about the products that you will need. We have, for example, nutrient solutions for leafy greens. We have the traditional and also organic. We have different kind of substrates. We have also different kind of pots for hydroponic production, for example, for a strawberry. And we also have this kind of system, like this is our grow rack, when you can grow leafy greens, like microgreens or lettuce. And you have everything in here, like the reservoir where you will put your nutrient solution. Everything is ready to use. The lamps are already mounted, so you won't need anything, just put your plant in. And this is our team. So we are very happy to be invited to this event. And we have a table over there. Deidre just went outside, but she will be there at the table. Please reach us with any questions that you have. We're happy to provide information about our products, and also that's my job, to provide information about the crops and the management that you need inside of your system. So that's all for me. Thank you.